Hi, my name is Bryson and I'll be presenting for the License Plate Detection for Mobile Applications group. The purpose of this project was to apply image processing to license plate images to determine the license plate's numbers. This group created an Android mobile application that allows the user to take pictures of license plates, send it to the server, and then receive the license plate number back in the app. The server looks for an incoming request to process an image from the app. Once this request is made, the server calls a function to store the image locally on the server, call the algorithm, and then wait for the algorithm to return the characters detected in the image. This response is sent back to the device that made the request. The algorithm uses an image passed to it by the server and determines where the license plate is in the image using license plate localization techniques. Then character segmentation techniques are used to locate the specific characters in the license plate. Lastly, the direction of each pixel is calculated, and the result is used as input for the neural network to determine what character it is. After all the characters are recognized, the result will be sent to the server. By combining a mobile application, server, and image processing algorithm, this team's purpose was to create a functioning method to identify license plates using a mobile phone. The completion of this project allowed for a learning opportunity for students on the project as well as a foundation for future projects about similar topics. Moving on to the application. The app itself consists of functions that take the image and send the image to the server. The user interface of the app is shown below in Figure 1. The Capture Image button opens the camera and allows the user to take an image using the built-in Android software. The image is then displayed to the user on a bitmap in between the buttons. The Display Image button will display the image the user took and take them to the next screen, shown in Figure 2. The Upload Image button uses the Volley library to communicate with the server. It sends a post request to the server and the image is sent as multi-part data to the server. Once in the server, the image is processed. This processed image is then sent back to the phone and displayed to the user along with the license plate number. Moving on to the server, the first step on the server is saving the image file sent by the mobile app. The mobile application makes a request to the server to start processing the image. The server then saves the file, calls the algorithm to process the image. It then saves the output of the algorithm to a database with information about who requested the image using user IDs and sends the mobile device a push notification informing the user that the processing was complete. The second step is sending the results back to the mobile device. After the user receives the push notification on the device, they make a request to the server to fetch the license plate numbers. The server fetches this information from the database where it was saved earlier and then sends it back to the user. Now on to the algorithm. The first step of the algorithms is the license plate localization. The first step is to find where the license plate is on the color image. First, the color image is changed to a grayscale image using the BT709 transformation. The original image is shown in Figure 3 in the bottom left. Second, the Sobel filter is used for edge detection to change the grayscale image to an edge image. Last, it is found where it has the most edges, and this part is assumed to be the license plate, which is shown in Figure 4. The second step is license plate segmentation, and this involves further processing that is done to determine the approximate location of the characters on the plate. The amount that the image is rotated is calculated by the alignment of the characters and their skew from being flat. Once the license plate is rotated, characters are segmented based on the space between them, and that's shown in Figure 5. Then the individual characters are passed to a neural network to recognize the actual character, which is the third step, character recognition. This third step receives the image of the soon-to-be recognized character, and first the hog feature is calculated, which is the gradient histogram of each non-overlapping subimage, and the histogram values are used as input for a trained neural network. Then, characters with the highest probability of being in the image, as determined by the neural network, is chosen as a result, which is shown in Figure 6. After recognizing all the character images, the license plate number is then returned to the server, so then it can be relayed back to the app. So we've come up with various results as we've done this project, and the three components that we discussed will all be connected in order to complete the app. The app will be responsible for taking the image and saving it as a file, and a request will be sent to the server to send the image to the server. Once at the server, the image will be saved to a database located on the server along with metadata related to the image. The server then runs algorithms Python code to process the image and receive the license plate number, and the server will then send this number back to the app for the user to see. During this process, testing has been done specifically on the algorithm side to test the accuracy of our program. The overall goal is 80% accuracy, but there's not been sufficient testing yet, so the numbers shown in Table 1 will not be the final accuracy ratings. Future work will involve tuning and testing these algorithms, and as you can see in Table 1, for the localization and segmentation segments of the algorithm, we have 80% accuracy, and the character recognition, right now we have 93%, but they will, be different as we move on. Thank you.